Welcome to the course Fundamentals of Remote Sensing, designed for students, researchers, and Earth observation enthusiasts. This course focuses on building strong foundational concepts in remote sensing with a special emphasis on microwave remote sensing, the backbone of radar-based Earth observation. With the recent launch of NASA ISRO Synthetic Aperture Radar, and its commitment to freely available data, it's the perfect time to understand how microwave sensors work, how SAR imagery is interpreted, and why radar remote sensing is vital for environmental monitoring, disaster management, agriculture, and more. In this series, we will cover what is remote sensing, why microwave remote sensing matters, SAR principles and polarimetry, real-world applications and data analysis insights. Whether you are preparing for research, fieldwork, or data analysis, this course will help you master the basics and build confidence for working with modern remote sensing datasets. Don't forget to subscribe to my channel and turn on notifications to stay updated with new lectures and tutorials. Now let's begin with lecture 1, what is remote sensing? This is the overview of today's lecture. First, we will see what is remote sensing, then types of remote sensing. After that, we will discuss the advantages and disadvantages of microwave remote sensing. After that, we will see applications of microwave remote sensing, and then we will also see imaging radar. So, what remote sensing is? Currently, you are watching my lecture on your monitor or on mobile device. Your eyes are working as sensors which are not in physical contact with the monitor or a mobile device, but still can sense the information and perceive it remotely. Similarly, satellites can extract the information of target on the Earth's surface without being in physical contact with it. In literature, it is defined as it's an art and science of making measurements about an object or the environment without being in physical contact with it. The figure here shows different targets on the Earth's surface like grass, water bodies, forest, then trees, then bare soil, roads, buildings, etc. The sun is acting as a source of energy. The solar radiation is reflected by the object on the Earth's surface, which is received and processed by the satellite. Now you will think, why remote sensing? It's very difficult to collect the information of the Earth's surface manually. Satellites can cover large area periodically and at the same time. Information can be collected periodically as satellites can revisit the same location. Various frequencies can be used to acquire the data from the Earth's surface. Remote sensing started in mid-19th century using balloon. Later people started using kites with camera mounted on it. Now you are aware that we are using satellites and drones to capture the data. Okay, so the aerial photography we can do using both the techniques nowadays. There are two types of remote sensing techniques, passive and active remote sensing. In passive remote sensing, as shown in the figure on the left hand side, there is no artificial source of energy. In this, sun acts as a source of energy and the solar radiation reflected by the targets on the earth is received and processed by the satellite or a sensor. On the other hand, in active remote sensing, radar emits the electromagnetic spectrum which is reflected to radar from the target on the Earth's surface. You must have studied electromagnetic spectrum in physics. Few regions of electromagnetic spectrum are used for imaging. The digital image processing which we have in the curriculum covers only visible spectrum. All our mobile cameras works in visible spectrum. This is the band which can be perceived by human being. The remote sensing in this region is known as optical remote sensing. Along with visible spectrum, the imaging can be done in ultraviolet, near and mid infrared, thermal infrared, and micro regions of electromagnetic spectrum. As mentioned just now, optical remote sensing uses visible spectrum. All of you must be using Google Earth app. What is that? It shows optical images of Earth's surface along with some information. Cameras are used to capture the information. The problem in optical remote sensing are we cannot take images during night time as it needs sun which acts as a source of energy. The images gets affected by clouds, rain, fog, snow, smoke and smog, and it cannot penetrate soil, vegetation, snowpack and ice. Each target on the earth may not have unique signature. For example, vegetation. It's very difficult to classify one type of crop from another using optical remote sensing. Now we will see the advantage of microwave remote sensing over optical remote sensing. Microwave remote sensing is independent of sun energy, so can work during night time also. It can penetrate atmosphere in almost all weather conditions like cloudy, rainy, foggy, etc. So it is known as all weather and all season satellites. Microwaves are sensitive to the dielectric properties of target. It can classify targets based on dielectric properties. It can also be used to measure soil moisture. Microwaves are also sensitive to the surface roughness. Due to all these properties, microwave can give unique signature of the target on the Earth's surface. So by using microwave remote sensing, we can actually classify the type of vegetation, the type of crops and many other things. There are few disadvantages of microwave remote sensing. There is a complex interaction between microwaves and targets, and due to which the system becomes very difficult to understand. Speckle is a type of noise which is present in microwave data. Because of it, visual interpretation of data becomes difficult. Microwave remote sensing is a side-looking radar, so the topographic effects are visible, and to understand microwave remote sensing and to work with it requires lot of knowledge of mathematics. You must be aware what radar is. Radar stands for radio detection and ranging. It transmits pulses of microwave signals in the direction of target and records the strength of the received signal along with the time required to return it back. There are two types of imaging radar systems, spaceborne and airborne. In airborne, the sensor is attached to the aircraft as shown in the figure. And the spaceborne, the sensor is attached to the satellite. The effect of altitude is less in case of spaceborne as it is far away from the Earth's surface. Spaceborne radars are more stable compared to airborne radar. The advantage of airborne radar is it can acquire high resolution data from different look angles and look directions. There are different applications of imaging radar. It can be used in oceanography to study the bottom topography, wave forecasting, marine climatology. It can be also used for snow and ice monitoring, to map and monitor the use of land, forestry, and the agriculture area. The data can be used to update the thematic maps very frequently and cost effectively. It can be also used for flood monitoring, to study soil moisture, wetlands, and the surface movement caused by earthquakes. It can be also used for glacier advancement, and there are so many other applications in which this data can be used.